Okay, in Unit 3, we're going to talk about powers, roots, and radicals. It's very important to remember in this chapter we are talking about real numbers only, so there will not be i's in any of your answers. So when we're talking about powers, let's talk about perfect squares, 0, 1, 4, etc. It's important that you recognize that a number is a perfect square, or a perfect cube, or a perfect fourth, fifth, or sixth. It's actually more important that you can recognize that these numbers are a perfect square, fourth, etc., than actually knowing that, 2 to the third is 8, or, I don't know, 2 to the fifth is 32, etc. All right, square roots we've already done. You know how to simplify a square root. Simplifying cube roots is very similar. The cube root of a number is the number you would get when you cube it. So, for instance, if I said, what is the cube root of 8? You would ask yourself, well, what number do I have to raise to the third power to get 8? And your answer would be 2. The symbol for a cube root looks very similar to a square root, except that you're going to put the number 3 here. This is called the index. Any number in the cube list could be cube rooted to get an integer. For instance, the cube root of 64 is 4. The cube root of -8 is -2. So now we can have negative numbers underneath your radical and still get a real answer if this index is an odd number, because -2 times -2 times -2 times -2 would give you -8. The cube root of 27 is 3. And the cube root of -125 would be -5. The fourth root is going to look very similar, but your index now is a 4, and the fifth root, your index now is a 5. So the general symbol of the nth root of b would look like this, where n is the index, and it would always be a positive integer, and b is called the radicand. So when n is even and b is positive, so my index is even and my radicand is positive, I will always have an answer that is one positive number. For instance, in this case, 2. When n is even and b is negative, for instance, the square root of -9 or the fourth root of -81, the answer would be not real. So we're not going to deal with any i's in this chapter, so your answer to this would simply be not real. When n is odd, there is only one root. If it is positive if b is positive, and it's negative if b is negative. So for instance, the cube root of 125, your index is positive, your radicand is positive, your answer will be positive. The cube root of -125, your index is positive because it's always positive, but your radicand is negative, so your answer will be negative. If you have something like this, the cube root of -2, where you cannot simplify what's underneath the radical, then you simply just pull the negative out and leave it as the negative cube root of 2. So simplifying radicals, right? Go ahead and try these and see if you can do them. First one's 3, 2, -2, and not real because it's an even index and a negative number. So we used to separate square roots by saying the product can be broken up into the square root of a times the square root of b, again, if we're talking about real numbers. And now we can do the same thing as long as the indices are the same. Again, as long as we're talking about real numbers. So if I have the cube root of 24 and I want to simplify that, I can break that down into 2 cube roots, but I'm looking for one that might be a perfect cube. For instance, the cube root of 8 times the cube root of 3. Well, I know the cube root of 8 is 2, so I can simplify this down to 2 times the cube root of 3. Go ahead and see if you can simplify these four. So this one simplifies down to 2 times the 4th root of 5. Negative 2 times the 5th root of 2. Remember, you always pull the negative out of the radicand. Negative 3 times the cube root of 3. And simply negative 5th root of 6. Now we can use this cube rooting now to simplify or to solve equations, which if you remember in the last chapter, we could only do it if it was a linear or a square root. But since we are now only dealing with real numbers, we can take cube roots and fourth roots and solve equations that way. So I can simply take the cube root of 54 and then simplify that radical. Now there could possibly be some imaginary solutions to this if we graphed it, but we are not interested in those. So 2x fourth minus 6 equals 58. You're going to solve this like you would do anything else, where you want to get your x term alone. So you're going to add 6 over, divide by 2, and now you can take the fourth root. But anytime it's an even root that you are taking, you must remember that you're going to need the plus or minus in front of it. So your answer would be x equals plus or minus 2 times the fourth root of 2. Solving this one, again, now you want to get the term that has the x in it alone. So first thing you want to do here is divide by 3. And now because this is in parentheses, you can take the 5th root of both sides and then add the 2 over. Try this one and see if you can do this one on your own. Right, you would add 5, divide by 3, and take the 10th root of the answer. Again, because your index is positive, you can't forget to have plus or minus. I meant your index is even. All right, solving equations by nth rooting. It's the same process as solving by square rooting. If you take an even root, you have to have a plus or minus. If you take an odd root, the answer has the same side as the radicand. Radicand's positive, your answer's positive. Radicand's negative, your answer's negative.